Good morning to all of you. Today I'm going to talk on the application of the homogeneous system. For example, from this given network circuits, where it consists of the left loop and the right loop. Okay, C is 2 times 10 to the power negative 4. The resistance is 20 ohm. The inductance is 0.5 Henry. Find the current I1 and I2. Okay, so first of all, we have to model the network circuit into the homogeneous system in terms of di1 dt and di2 dt. Okay, first of all, consider the left loops. Consider the left loop here, where we have here, this will be the VC, this is the VR. Once for left loops, we have here, so VC plus the VR equal to 0. Okay, we would like to find the I1 and I2, and then VC can be written as 1 over C integral I1 dt. VR here we have notice, because this is a network circuit, we have the I1 and I2, where I1 and I2 are actually opposite direction. If we consider the I1 is positive, then I2 will be negative. Because one is going down, one is going up, this will be negative. That's why we have the R answer here, I1 minus I2 equal to 0. That's what we have here. The Q1 over C is equivalent to integral of 1 over C integral I1 dt. Okay, to eliminate the integral, simple here, we have the ddt both hand side of the equation from left loops. So if we ddt integral I1 dt, once we will get this will be I1 over C plus this will be R. This is I1 prime or di1 dt. This will be I2 prime equal to 0. That's what you get here. I1 over C, where this is the C value that you plug in here. I1 over C. Okay. Then the R is 20. R20. Then I1 prime minus I2 prime equal to 0. Okay. Simplify here. You get 5000 I1 plus 20 bracket I1 prime minus I2 prime equal to 0. Because the homogeneous system is actually, we would like to have equations in terms of, let's say, di1 dt equal to, for example, in terms of A is a coefficient, means in A I1, let's say plus B I2, and then we want di2 dt. Let's say this will be ci1 plus c, and then this is di2. Then you can change it to matrix form, where this will be I1, I2 equal to, this will be your matrix A, B, C, D. This will be your, cannot see, I1, I2. Or in the matrix, okay, form will be the I prime equal to A I, where the I prime is a vector, this is I1 prime, I2 prime, or di1 dt, di2 dt, the matrix A, B, C, D. Okay, the vector I consists of I1, I2 that we are going to solve. Hence, this is the homogeneous system. So in order to get the I prime equal to AI, that's why we would like to get the first equation to be di1 dt. Hence, okay, from here, we make the I1 prime as a title. So we have 20 I1 prime equal to, okay, this is minus 20 I2 prime, bring to the right hand side become 20 I2 prime, and this term 5000 I1 will bring to, okay, right hand side become minus 5000 I1. Okay, and then we mix the coefficient for di1 dt, or I1 prime become 1 by dividing both hand side by 20. So we get equation 1 here. Will be the first equation that we want. di1 dt equal to ai1 plus di2. But not yet, because we still have this term, I2 prime. So we have equation 1 first, and then from the, we haven't arrived to this equation. Okay, then we look at the right loop first. Okay, I first erase this one. I think the right loop, where we have the inductor, mean the VL. Okay, I erase this thing first. Okay. Okay, for the right loop, and notice we can have here VL here equal to VR. Okay, VL we have, and the current passing through the inductor is I2. That's why you have L I 2 prime VR here, which is R I1 minus I2. So this is R I1 minus I2. Okay, that's what we obtain here. This is actually R I2 prime. L. So I make L, which is 0.5 in here. This is actually L, okay, I2 prime equal to the VR here. Okay, solving for one time of I2 prime, we divide both hand side by 0.5 or multiply by half. 0.5 is actually 0.5 is actually half. Okay, so not multiply. So it's either you multiply by 2 or divide by 0.5. Multiply by 2, so 40 I1 minus 40 I2. Okay, so the second equation is already in the nice form. As I said just now, di2 dt equal to, this is ci1 plus di2. However, the first equation still in terms of I2 prime. What we want is actually, as I said just now, I want I1 prime equal to A I1 plus bi2, and then I2 prime equal to ci1 plus di2. Okay, equation 2 already in this form. However, equation 1 still in terms of I2 prime. Hence, okay, substitute equation 2 here, equation 2 into here. Substitute 2 into 1. That's why you have, okay, I1 prime. This is actually I2 prime, which is 40 I1 minus 40 I2. Then minus 250 I1. So 40 I1 minus, okay, 40 I1 collect with negative 250 I1. So you have minus negative 210 I1. So this will be, okay, minus 40 I2. Okay, so this will be equation 3 will be the first case difference, the first order, the first equation of the first order differential equation. And you have I1 prime, or actually this is actually what we call di1 dt equal to negative 210 I1 minus 40 I2. And then put the second equation into become the second first order differential equation, di2 dt. Yeah. Okay, this is di2 dt equal to 40 I1 minus 40 I2. 40 I1 minus 40 I2. So this is what we call the homogeneous system. Homogeneous system. Because, okay, it's actually plus a 0 vector. So this becomes homogeneous system. If it plus a constant or a vector consists of exponential term or trigonometric term, then this becomes non-homogeneous system. Okay, and normally if the network circuits, okay, if our network circuit, okay, do not have the voltage, then we'll use a homogeneous system. Okay, so now this becomes like a mathematics, okay, a homogeneous system. So to solve the homogeneous system, just now the first step is model until we get a homogeneous system. Okay, and in the final later on, okay, you have to depend on the question whether they want you to model or you can straight away solve on that non-homogeneous from the homogeneous system. It depends on the questions. So we have modeled the homogeneous system. Now we are going to solve the homogeneous system, means we want to solve for I1 and I2. To solve the homogeneous system, first step, finds the eigenvalue of the homogeneous system. Okay, to find the eigenvalue of the homogeneous system, we'll let determinant of A minus lambda I equal to 0. Okay, this is a determinant of A minus lambda I equal to 0. Solving the determinant of A minus lambda I equal to 0. Okay, remember how you solve the determinant? Put the determinant form. Okay, your matrix A minus lambda I will effect at the main diagonal. So here minus lambda. To solve the determinant, remember the product of main diagonal. So it's negative 210 minus lambda multiply negative 40 minus lambda minus product of the other diagonal. Minus, and this is negative. So minus with negative become positive 1600 equal to 0. Okay, expand expand here. So you have negative 210 by negative 40 8,400. and then negative 210 times negative lambda, negative become positive. Okay, so this one you have positive 210 lambda, and here negative positive plus 40 lambda, so total is 250 lambda. So negative lambda times negative lambda, you have positive lambda squared plus, okay, 1600. So you have lambda squared plus 250 lambda, okay, 8400 plus 1006, so will be 10,000. Okay, you may solve it using your scientific calculator, and we get two actually real and distinct roots. Lambda 1 is negative 200, lambda 2 is negative 50. So the following step finds the corresponding eigenvector. Okay, when lambda 1 is negative 200, to find the first eigenvector v1 by solving the homogeneous, okay, equations a minus lambda, homogeneous system a minus lambda 1 v1 equal to 0. Therefore, lambda 1 equal to negative 200. Okay, this is determinants. You want to change back to matrix, just change the straight, okay, mean the determinant symbol to the round bracket. So bracket negative 210 minus lambda. Lambda is negative 200, so minus become plus. So this one become plus. This is actually negative 40 minus negative. Negative become positive. So negative 10 plus 200, you have negative 10, and negative 210 plus 200, this become negative 10. So negative 40 plus 200, we have 160. Okay, you notice that actually both row here are equivalents, or you can divide equation 2 here by negative 4. You divide the whole equations here by negative, okay, negative 4, then we get negative 10. Okay, this will be negative 40. So now it's proof that both equations are actually equivalent, means you have two unknown to be solved. However, the system reduced to only one equation, which is negative 10x minus 40y equal to 0. Here. Or x equal to negative 4y. So letting y equal to s, x will be negative 4s. So xy, y is 1s, x is negative 4s. Okay, by letting s equal to 1, you obtain the first eigenvector v1 equal to negative 4 and 1. Similar step by substitute, okay, lambda 2 into the homogeneous system a minus lambda 2 I, v2 equal to 0. Okay, the v2 we let it equal to, okay, xy. So for lambda 2 equal to negative 50, so this is actually negative 210 minus the lambda 2 is negative 50, so negative positive. So same thing with the element a22. So this negative 40 minus negative 50 become plus. So negative 210 plus 50 is negative 160. This is negative 40 plus 50 become positive 10. Okay, both equation is actually, when the row 1 is actually what we call equivalence to row 2. Okay, you can prove it by, if you divide row 1 here by negative 4. So you get 40, this will be 10. Hence, is proof that actually row 1 equivalent to row 2. Means we have two unknown xy to be solved. However, it reduced to only one equation, which is 40x plus 10y. 40 times x plus 10 times 1. Okay, remember, okay, the product of matrix row times a column. You take this element, multiply this one multiply this one. So mean two unknown left to one equation. So this case we have infinite many solutions in terms of parameter s. Okay, so we divide by 10. This equation, if we divide by 10, we have 4x plus y equal to 0. So y is equal to negative 4x. Okay, normally we would like the left hand side here, the coefficient will be 1. So that okay, the eigenvector that you get will be integer number. So means 1y equal to negative 4x, and we always let the variable at the right hand side equal to s. So x equal to s, y will be equal to negative 4s. So x is 1s, y is negative 4s. By taking s equal to 1, v2 is 1 negative 4. Hence, the general solution of the homogeneous system will be, this will be A v1, B v2. In A v1 exponent, this is the lambda 1. Remember, the general solution will be A v1 exponent lambda 1 t plus B v2 exponent lambda 2 t. This is a v2, lambda 2 is negative 50, lambda 1 is negative 200, v1 negative 4 and 1. Okay, with this, thank you for your attention.